Okay, this will be the review for the 14.1, 14.2 test. I'm going to go over the two half sheets that we worked on, but before that I want to just get some of the basics, some of the stuff that was on the board for the last week and a half, so that's very kind of crucial to this stuff. So let me add that in here. Um, Basically, a couple things we need to remember. I think a lot of things are going to be based on um, kind of knowing the unit circle. Um, so there was really 4 points that we focused on when we graphed these things. And they came from, again, the unit circle. So coordinates of those, again, if it's a unit circle, the radius is 1. So this point would be at 1, 0. Up top, 90 degrees would be 0, 1. Over here, we'd be at negative 1, 0, and 0, negative 1. Okay, and again, that's 0 degrees, 90 degrees, 180, and 270. Okay, and what this whole chapter and unit was about was graphing trig functions, cosine of thetas and sine of thetas. Okay, and we eventually would add a bunch of shifts and amplitudes and all that stuff, but the basic ones are these two, and you have to know these two in order to change to make the more complicated ones. So let's just do a graph of each of these basic ones. If we wanted to graph these, let's do sine or cosine theta first. The trick is the x values, or the theta values, the thing you're plugging in, those are the angle measures. And so we usually just use the ones that we wrote on our circle. So we use 90 degrees, 180, 270, and then once we do the full circle, we're back to 360, and of course we start at 0. And the thing to remember is that the cosine values are the x coordinates. Okay, so cosine goes with x values. When we do sine in a minute, sines go with y values. So on the circle, the cosine of each of the angles are just the x coordinates. Okay, because that's kind of like the adjacent side. So if we plot these as we go around here, the cosine of 0, we're going to start up at 1. Okay, so that's the y value. And then as you work your way around the circle, notice, think about what's happening to the x coordinates. Okay, they're getting smaller and smaller. They're going down to 0. So by the time you get to 90 degrees, the x value there was 0. So the cosine of that is 0. And then as you continue to work your way around, the x values are still getting smaller. The x coordinates are going to negative 1 by the time you get out to 180. Okay, and then we're just going to keep going past 180 degrees. Now the x values are getting a little bit bigger. They're coming back and back and back, and they finally get back to 0 at 270. And do the full circle, and they will come all the way back to where we started, up at 1. And then from there, you're just going to repeat. You can go around the circle again. So this thing is going to eventually come back down to 0 again, and just kind of keep doing the same thing. So we can kind of see the pattern here again, and you just got to recognize it's actually a nice rounded, smooth curve. It's not rigid and straight lines or anything. So that's what your basic cosine curve will look like. Okay, and then we could follow the same kind of pattern. I'm not going to do all the details, but for a sine curve, doing the exact same setup, we use the same x values. Okay, again, the angles are still 90, 180, 270, and 360. And if you did the same process, if you worked your way around the circle and just focused on y values now, you could get the basic sine shape. Okay, and recognize that one actually starts at 0. And again, I'm going to do this one a little quicker. It goes up to 1. By the time you're at 180, it's back down to 0. 270, the sine, the y value down there is negative 1, and then back to 0. Okay, so this one kind of does this shape, and then of course it's going to keep repeating itself in both directions. Okay, so those are some of the basics. We're going to use those, and then what ends up happening is they add some things that change a little bit. Sometimes there'll be an a value out here for amplitude, and then you'll have your function, either your sine or your cosine. There's sometimes a b value in there, then you'll have your variable, and there may even be a plus or minus something in there and a plus or minus something at the end. So that just takes the original ones and just changes them a little bit. And the real quick rundown of that, of course, the a is going to change the amplitude, which we'll talk about. That's going to be basically the height from the center line. Okay, so that'll just make the graph taller. The b will change the period, and these original ones, the period was 360. If there's a b value there, you just have to take the 360 and divide it by that. Okay? Or if you're in radians, 360 is the same as 2 pi radians, and a lot of the word problems, pretty much all the word problems are going to be in radians, so we're going to use 2 pi. And again, this will give you the new period. Okay, so we'll do that. And then the possible shifts. You might have a horizontal or a phase shift inside the parentheses there, where you just take the points and slide them left or right. And then finally, the last thing they can do to you is a vertical shift. Take all the points, slide them up or down. Okay, so let's do a couple examples on the half sheets and put this all together. Okay, so this was the, let's do the other one first. Let's do the 14-1, and then we'll come back and do the practice test. So this was kind of an application with the population of field mice modeled by an equation that they give you. So there's a few things you can do. You can throw it in a calculator if you want, use a table of values. If you do that, make sure you're going to want to use an extra set of parentheses. I would do 3,000 plus 1250, and then when you press sine, it's going to open a parenthesis. Okay, and we're taking the sine of pi over 6 times t. So what I would do is put that pi over 6 in its own parenthesis, and then you're going to have to use the x instead of t. And then make sure that that x is in parentheses also, because these big parentheses are saying that's what you're taking the sine of. So it needs to be pi over 6 times x, all in parentheses. And then we already got the 3,000 at the end there. Okay, so you could throw that in a calculator, radian mode. Okay, again, radian mode, unless you're dealing with degrees in a triangle, which this one really is not. The x values here are as a time unit, months, so it's not degrees. So radian mode, and the calculator will give you the values. I kind of like to set these up without a calculator too, kind of manually, just to make sure everything works, and we can kind of do like we set up on the first page. So what I would do, we know the amplitude is 1250. We know there's a vertical shift here, this 3,000. Let's figure out the period so we know where to put our marks along the x-axis. So the period is going to come from using the b value here, and this pi over 6 is the b value. Okay, so let me do this here, then we'll erase it. The period is always 2 pi divided by the b value. Okay, so 2 pi divided by pi over 6. We're dividing by a fraction. I'm going to multiply by the reciprocal. Okay, and in that case, we can recognize the pi's cancel out, so this thing will just actually equal 2 times 6, which is just 12. So our period, this thing's going to take 12, and it's in months, 12 months to do a full cycle. So if we divided that into 4 equal chunks here, each one of them needs to be a 3-month cycle. Okay, so that's going to be our 4 values like when we drew them, when we draw these by hand. Okay, so the period's 12. Let's start getting some points here. Okay, now a couple ways to do this. So we know it's a sine curve, so we showed on the previous slide what that looks like. Now normally a sine curve would start at 0. This thing has the vertical shift of up 3,000. So normally it would go here and then go up to 1250, and then it would come down here and then back to 0, and it would look kind of like this. Okay, this is without the phase shift, and it would start to repeat. But what happens in a lot of word problems, we're not going to have a negative number of, what is this, mice here. So all these points down here kind of don't make sense. So that's what the plus 3,000 is going to do. It's going to shift everything up, and it's going to make those numbers positive. Okay, so what will end up happening is this 0 will actually be up at 3,000 now. And then we can do the same pattern. I know this is now my center line. Okay, instead of the x-axis, that's where we're going to go from. So to get to the first point here, the 3-month mark, I know the amplitude was 1250, so I need to add 1250 to that, so I should be up around 4,250. And then at 6 months, I get back to the midline. 9 months, I'm 1250 below where we were, so that would be what, 1750? Okay, so that was like from the 3,000, 1250 less, and then by 12 months we're back where we started, and then it's just going to start repeating itself. Okay, so this is kind of what ours would look like. Okay, and again, use the calculator, verify those if you want. Get the table of values, plot some points. Feel free to do that. Okay, but that's what this graph looks like. And then there were a few questions on the back. What is the period? We found that. The period was 12. Again, we did 2 pi divided by pi over 6. and we ended up with 12, and the unit was months here, and that seems reasonable to me. If 12 months is a year, so it seems like the pattern would continue the next year. Something to do with the weather affects how many mice there are, so each year you get some sort of repeating pattern. So that seems reasonable. Part C, if month T equals 0 is March, how many would be expected in April? Okay, so the key was this thing started in March, so this 3,000 value was for March, so the next month would actually be April. So whatever that value is in April um, would be our answer there, and you can get that from the table on your calculator. It should be 3,625. Okay, so that was referring to when x equals 1 or when t equals 1 on the calculator, 1 month later. Okay, the maximum number, whenever we graph these, again, we started at 3,000. The maximum we can see is up here. That's when it starts to come back down. And the little trick on that, that's just whatever you started with plus the amplitude. Okay, so that was 3,000 plus the 1250. That value should be 4,250. Okay, and when did that happen? What month? So again, if we started in March, this would be April, May, so it had to be the third month after that, so June. Okay, so the maximum number happens in June. Nice warm month, a lot of mice. Minimum number, again, if we look up at our graph here, we can see the minimum occurs down here, and that is just the 3,000 minus the amplitude. Okay, so that ended up being the 1750, and that was in the 9th month after March, so that ends up being December. Okay, and again, that seems to make sense. If it's cold outside, there might not be as many mice around in the winter. And last part, when does it fall below 2,500? So this is just kind of an estimate here. If we use our graph, so 2,500 happens about there, so that would be around 6 to 7 months after March. Okay, so like maybe the 9th or 10th month of the year, September or October, something like that. That's when it first falls below 2,500. Okay, so that's that. And then the practice test, sorry, this printed a little small. Hopefully it's viewable here. Just some basic graphs, not word problems or anything. So let's set this up. I don't really like how this graph paper looks, but we'll do our best here. So the equation is y equals 2 cosine of 4x, and it wants you to do it in radians. So the domain, that's kind of the easy part. The domain's always going to be all real numbers for any sine or cosine graph. So the ones we're doing this year, domain's going to be all reals. The range is going to be whatever the amplitude is, because in this case there's no shift up or down. So since that amplitude is 2 from the beginning, that's going to be our range also. It's going to be between 2 and -2. So I would write that. Let's do this over here. The range is going to be all y values, and we'll see it on the graph in a second, between -2 and 2. Okay, so that's going to be our range. Let's get the period here. 1, 2, 3, 4. Period. Okay, this one that can be a little tricky sometimes, especially with radians. Always 2 pi divided by the b value. Okay, or if it were degrees, it's 360 divided by the b value. This one had a b value of 4. So the period's 2 pi over 4. And we do want to reduce. 2 over 4 is 1 over 2. So the period is actually just pi over 2. So that'll be our fourth little piece here. Now, how are we going to get the other pieces? The first one is 1/4 of the way there. Okay, so some people like to say, I'm going to take pi over 2 and divide that by 4. Okay, and then they kind of get stuck. They see a fraction and the division. It's actually just, if you think of this as 4 over 1, multiply by the reciprocal. Multiply by 1/4. It becomes pi over 8. Okay, so that would be our little first checkpoint here, pi over 8. And now we should be able to just count them. If each interval is pi over 8. Okay, so the second one is 2 pi over 8. So this one here, 2 pi over 8, which reduces to pi over 4. 2/8 is 1/4. Okay, so 1/8, 2/8, so the third one has to be 3/8, 3 pi over 8. And then just make sure that fits with the one we put, the fourth one, would that be 4 pi over 8? Okay, yeah, that's the same as pi over 2. Okay, so we got that set up. We got our amplitude set up. Now we just need to remember from the very beginning, what does a regular normal cosine look like? It's going to start up at the amplitude and work its way down because the x values get smaller. As you go around the circle, then they start to come back. Okay, so something like that. Okay, so that's what we'd be looking for with number 1 there. Okay, and again, you can see the range there now, the minimum and the maximum, so that's why our range was all values between -2 and +2. Okay, number 2, this one, they didn't quite give you the form in the completely correct, or the equation in the totally correct form here. There's one little thing we got to do. So first off, it's in degrees, so that's kind of nice. But the thing that wasn't right, this 3 technically needs to be out in front there. Because the phase shift in this one's actually not 45. If the 3 is in there, it changes things a little bit. So what you want to do, if the b value, that 3 is inside, you want to bring it out. And what it's going to do is think about 3 getting times by x, and then 3 getting times by 15. That would distribute to be the 45 that it was supposed to be. Okay, so the phase shift is actually 15. Okay, so we'll do that in a second though. Domain, all reals again. Range, let's talk about that in a second. Amplitude we can see is the 4 at the beginning. Now the period, okay, again, this one's degrees, so 360 divided by this 3 is the b value, so the period's 120. Okay, so let's get our graph set up. Okay, so 120 degrees there. So this one, it's a lot easier with degrees. You divide that by 4, you get a nice whole number, 30 degrees. So each little chunk will be 30. And what I do, since this one has some shifts in there, it's going to have 2 things going on. We're going to shift everything to the right, and we're going to shift up. So what I do is I draw a nice dotted one first without any shifts, just a regular old sine curve, and then you have like something to use to shift. So let's set up our amplitude of being 4. So we're going to go 1, 2, 3, 4. And I see with the shift I might need a little more room, but we'll do that in a second. So a regular sine curve would just go origin, up, back to 0, back down, back to 0, and then repeat. So I'm going to do this dotted because, again, this is not my final answer. This is just kind of like work we're showing here. So that'll keep going. Okay, so now we can do the shifts. That's 4 sine of 3 theta right there. The shifts say go to the right 15 and go up 1. So if we take each of our points and do that, so looking on your graph, the way I set mine up, 2 little grid marks was 30 degrees. So to go 15 would just be 1 grid mark, and then in the y direction I have to go up 2 basically. That's how I set my scale. That's really like up 1. So that first point slid up here. Second point, I got to go over. I'm going to run out of space here, so it's going to actually be up here. Over 15, up 1. This bottom point, over 15, up 1. And over here, over 15 and up 1. So my scale, I probably should have done a little better, but that's good enough. That shows me the shifts, and that's our final answer. Okay. So what was our range here? Okay, normally if the amplitude was 4, it would be -4 to 4, but we had that shift, so those both got 1 bigger. So the lowest this thing ever got was -3, and it actually went up to 5. So -3 less than or equal to y less than or equal to 5 for the range. Okay, this one, very, very similar to the one we actually did. So let's see, maybe I'll just put the answer up here real quick without spending too much time. That's just like the other one on the first page. So again, my thought process, I see a vertical shift, so I know 400 is my midline. If we find the period real quick, 2 pi over the b value. This one had a b value of pi over 2. Okay, so again, if you do the multiply by the reciprocal deal here, it's 2 pi times 2 over pi. Okay, so the pi's cancel, and this just ends up being 4. So this one's kind of perfect. The period's 4, so it's actually just going to be 1, 2, 3, 4. So that worked out nice. And then the amplitude is 250, and it's a sine curve. Okay, so what I'm going to do, it's a sine curve. Sine usually starts at 0, but with the vertical shift, this one will start up at 400. Now the amplitude is how high I need to go from there. Okay, so in my first interval, I need to go up 250 more. So I'm going to be up at 650, come back down to where we started, go down 250, get back to where we started, and then start to repeat that pattern. Okay, and then we can use that to determine the maximum. So the maximum is going to occur up here, so that would be at 650. Okay, so that was, again, very similar to the other one. All right, and the last one, the old Ferris wheel problem. It's printed really small here for some reason. So let's see what we got. A little platform, the Ferris wheel on it. Right, we know the radius of the wheel was 12. The platform was 2. And we want to figure out, what does this thing look like? What does our height look like as time goes on? Okay, so let's set this up. 1, 2, 3, 4 little intervals always. And it's going to take 20 seconds to do a full circle here. Okay, so again, my trick is set this up like the other circles, like the unit circle. Get 4 points on there. And let's think about our height at those 4 times, and we'll think about how many seconds had to go by at those 4 times. So our x value here is seconds. The y value is height. Okay, and if it takes 20 seconds for the full revolution, that is the period. To do one cycle, one full revolution is 20 seconds. So each one of these needs to be 1/4 of that. Okay, so let's get our heights now. We can throw 0 on there too. So when we first start, because of the platform, our height is at 2 meters. Okay, our height off the ground, 2 meters. Once we get to this point, which is 5 seconds, 1/4 of the way around the circle. Again, think of this radius is 12, so we're 12 meters plus the platform was 2, so we are up at 14 meters tall at that point. Okay, then we keep going around, we're halfway around, we're at the highest point, 10 seconds have gone by. We're at 12 plus another 12, 24 plus the platform, we're up at 26. And then we start to do our little come back to earth here, come back down, we're at 14 again. And then the 20 seconds we're back at 2 where we started, and we repeat the ride. So, okay, so that would be our height over time here. Okay, so let's think about the equation here. Again, the midline, I think it's helpful to think about the center line. The midline here is 14. Okay, that's the point where we go up and down from 14. And the distance that we go up or down, that's the amplitude. So from 14, we went up to 26 and we went down to 2. So that sounds like an amplitude of 12 to me. Okay, and what a coincidence. That's the radius of the wheel. So the amplitude's 12. We know the period was 20. So the b value for our equation, again, we're in radians here, it needs to be 2 pi over the period, 2 pi over 20. And let's just reduce that exactly. 2 over 20 is 1 over 10. So pi over 10. So that's our A and our B. And then as far as any shifts, again, the midline was up to 14, so we had a shift of up 14. So let's put all those together and write an equation. Okay, so this one's going to be y equals, again, any problem like this is actually a negative cosine curve because it starts at the bottom and then goes up, up, down, down. Okay, so it's a negative cosine. The amplitude was 12. Okay, the b value was pi over 10. And then we throw our variable in, t, and then throw the shift on there, plus 14. There's the equation. Okay, and you can check it out, make sure you're in radians, and the table should match up with what we have there.